Good afternoon, Francis Schaefer, Precision Soil Management, Redfield. I'd like to explain some analysis we're doing on harvest from a spring application of a product called Carbon Cycle. And what this client did was they sprayed some strips in soybean fields, and Carbon Cycle is to break down residue into its nutrients to, to provide to the growing plant. So this is, in this field, this is where the strips of Carbon Cycle were sprayed. Now, when I got the data back, I had to decide how I wanted to analyze the data to present it. So one, it's an accurate representation of what really happened in these areas. And two, delineate out the different effects on different management zone soil types. So what I did was I came up with this idea that I needed to block off and analyze where the carbon cycle was and avoid any anomalies in the field, such as headlands, which are turnarounds, uh, wet wet spots. And then instead of comparing where the carbon cycle was to the entire rest of the field, I wanted to focus just on either side, which has management practices that are way more similar and soil types that respond similarly to their management. So this is what I came up with. This area one, carbon cycle. Area two, no carbon cycle, and there's on either side of area one. This is area three, carbon cycle. Area four is on either side of area three. Four does not have carbon cycle. So that's the first step. The second step I had to come up with was okay, now this is managed by soil type. So I need to be able to separate each soil type within each of these areas, so I'm not comparing this whole area as one soil type against these two areas as a different soil type. It's not a fair comparison. So what I did is I had the soil management zone cut down, and these are the soil types within the carbon cycle and the non-carbon cycle control areas. So zone one, you can see how it crosses into and through the carbon cycle into the non-carbon cycle. Zone 17 here, same thing. So we compare zone 17 in the carbon cycle to zone 17 yield outside the carbon cycle. And this is the results we came up with. Okay, now let me redo that. Let me grab this map and slide it over. Apologize for that. Okay, area 3 is over here, if you remember. Area 3, right here. It's got zone 17. That's carbon cycle, 52.8. Now we come down compared to zone 4 because that's on either side of zone 3. Zone 17 is 40.2. Carbon cycle area 3, soil type 2 is 52 bushels, where there's the carbon cycle in here. And 4, zone 2, is 46.1. Carbon cycle, soil type 3 is 49.7. Here, no carbon cycle, soil type 3 is 44.4. And then zone 1, carbon cycle, is 48.5. And non-carbon cycle is 42.6. Now, it shows to me that the carbon cycle application increased in an aggregate in area 3 from to 50.9 from 44.4. So that's a fair amount of bushels. The thing to keep in mind is how many acres of each of those soil types there are to decide whether that's a significant amount of information to make that judgment. Now I'm going to compare this zone 1, where there's carbon cycle, area 1, with the area 2. Area 1 carbon cycle, soil type 3, 48.1. Area 2, no carbon cycle, soil type 3, 43.5. Area 1 carbon cycle, soil type 2, 47.6. Area 2, no carbon cycle, soil type 2, 45.3. Area 1, carbon cycle, soil type 1, 44.7. Area 2, no carbon cycle, soil type 1, 43.6. Now, there's an anomaly in this field, and it affected this test area, and we sprayed right through it, and it was tillage that was done in 2020, and it goes right through the carbon cycle area. Goes right through it. Right through it. Right in the heart of both of them. And this one is clean. So keep in mind that when you're doing a test that there might be some historical management that affects the test results, and you've got to somehow figure out, okay, what is causing this difference? Is it only what we're testing, or is it some historical um, management practice? As you can see in summary, the carbon cycle definitely produced a yield benefit well above cost of application. Francis Schaefer, Precision Soil Management, thanks for listening.